When we open it up, we have these round things here, 1, 2, 3, and 4. These are our variable frequency drives, or VFDs. So these are going to control the motors, which is going to be down this side. So I don't know if anybody's got a screwdriver. Again, we can pull this side panel off. Keep tilting it back, there you go. So our VFDs control the motors. The nice thing with the motors and the VFDs, you'll see that they got a color and a number. So blue 1, red 2, a green 3, and orange 4. If you look at the motors are also color coordinated. So you know which one goes to which motor. So VFD 1, chamber 1, blue to blue, red to red, green to green, and then orange to orange. So of course, if you replace a VFD or a motor, it's not going to come with that numbering or the paint on it, but to start off with, it is there for you to help identify it. The other thing is the connections are also going to have color on them. So you can see which one is which, so it'll be on here, and then also if you look on the connection over here. Okay, so each one has 2 connections. So this has a short pigtail, the motor has a short pigtail, and then we have a connection between 2. So there's a connection point at the VFD, and then there'll be a connection point at the motor as well. Okay, so just be aware that there's both sides you need to check.
So it doesn't matter if it's a left-hand door or a right-hand door, the motors are still all going to be on the right side?
The only thing that changes is the door.
The door, okay.
Yeah, but the motors are always going to be on this side.
All right.
So here's our motors coming down, chamber 1, 2, 3, 4. VFD drives them. Up here we have circuit breakers. So these circuit breakers here are for the elements, which are on the other side. So these are all of our heating elements over here. So chamber 1, 2, 3, and 4. So these are all protected by these circuit breakers. Okay. The catalytic converter is also inside here. So we can open that up here in a little bit and take a look at that. 2 more circuit breakers here. These control our main power. So this is going to be power to our VFD and to our controls. Not our VFD, our power supply, and all of our main controls. Okay, so if the screen will come on, power's on, nothing's coming on. You can see there is a little door flap right here, so you don't have to take this whole thing up. You can just take the screw out and you can get to these 2 breakers, and you can see if they've been tripped, and you can try to reset them without having to go through the whole thing.
What did you say those breakers control on the side?
This is just your main power,
Okay.
for like the power supply and line voltage coming
This
in.
is your power supply?
Yep, this is power supply. So this is going to be your 208, 240 volt coming in, and then 12 volt DC coming out. Oh, this is 12 volt DC coming out. This is 208, 240 coming in. The 12 volt DC is going to be your solid state relays. This guy here, your relay, I think it's 1. It's going to energize. So lights are 12 volts DC, door lights 12 volts DC. So all that stuff's going to be controlled from this one here. This little transformer right here, this is what we call the voltage selection transformer. This is a very important transformer. It's what determines if the oven is 208 or 240 volt. Right? So if it's 240, I think you see on there, I'll tell you 240 volt, and it should be 12 volts AC out. So if you follow those around, those are coming right here to the control board, 12 volts AC out. So if it's 240, we should have 12 volts. If it's 208 volt, then the secondary side is going to drop. Instead of 12 volts, it might be 10 volts, 11 volts. And that's going to tell the control board what voltage we're running at, if it's 208 or 240. And that's important when we get to the solid state relays and how they turn on and turn off to control the heat. Okay. If you do not have voltage here or it's too low, the oven will not heat. There's no error code. So all chambers will just be stuck in preheat. The fans will be running, the oven will be on, it'll be calling for heat, but because it doesn't know what voltage the oven is, it won't physically turn on the elements. Okay.
Okay, so this has gone bad.
If that's gone bad, or maybe you're missing a leg of power coming into it, something like that, you're not going to do it. Which on a lot of the news sites, that's probably the number one thing we get, is that we just don't have the correct voltage to the ovens. It's a 3-phase, we have single phase, and then we get calls right away about, hey, chamber 2's not heating chamber, because that just happens to be the chamber that we need that third leg for. So just be aware of that. If you guys are getting calls on new stuff, a lot of times it's usually just we don't have the proper legs going into it. Control board. This is our control board right here. Front display. We have the display on the back is the interface board. So you can see that the square board there's the interface board. So when we talk about interface, that's that square board. And then we talk about the SD card. The SD card's right here. So snaps in. So we might always tell you, hey, check that SD card, make sure it didn't pop out. Pop it in. So you always want to turn power off, disconnect it from power, try to press it back in or pop it out, put it back in. Sometimes that's enough to just help it work.
What's going to cause your thermal overloads to trip?
Yeah. So the thermal overloads, this is one that happens a lot. You see the little light on the front. It should be an amber light, but the little screen's gone. So the little amber light comes on telling you to check fans. That's this bimetal right here. So if this gets above 120 degrees Fahrenheit, it's going to close. And then it's going to turn this light on. It's also going to close the relay, which gives you an error code on the screen that your oven overheated. Okay? The number one cause is cooling fans. Generally, the cooling fans are pretty good, but it's the filters get plugged up on the back. If those filters get plugged up, you can't pull air in, it overheats, it shuts down the oven.
Then reset them at the push buttons?
No, these push buttons here, so there's two. This is your high limits, but this is for your cavity high limits.
Okay, that's what I was.
Okay. Yeah, so this guy is just for the control area, and that's just auto reset when it cools back down. This one, yes, you'd have to physically pop if the chambers get too hot. Okay. So the top one controls top two chambers, second one controls the bottom two chambers. Right? So if you guys get a call, hey, top two chambers won't heat or are stuck in preheat, possible high limit, bottom, same thing.
And that's caused by maybe shelves in wrong?
Could be shelves in wrong, yeah, or just a lot of times it has something to do with how they put the jet plates in or don't put them in correctly, things like that happen.
Okay.
So those are not an actual thermostat or thermocouple or their thermocouple?
Yeah, if you follow, you can see the sensor bulbs are coming down through here behind the insulation, and they're just
So
they
they're
got
actual
little,
thermocouples and not sensors.
yeah.
So if it wasn't the fans, what would be our next step?
What's
If the
that?
fans are working properly, what would be the next step to
For
look at?
which? For which
If it's
issue?
An overheat.
overheating.
For an overheat, I mean, the first one is just make sure that the filters are clean.
Yeah.
That's been pretty much all of it.
It's always
and
been
then
that.
from there, check your fans. Also check the direction of the fans. So for you guys, it's pretty simple because your vectors all have the same. But if there's a filter, it sucks in, right? So if you got a fan blowing out, it's going the wrong direction. So maybe somebody did replace the fan but flipped it the wrong orientation, and now it's blowing out instead of in. And we're not getting that cooling air like we should. So
Gotcha.
this is something to always check for to make sure all the fans are going the right direction. They're
Fans
should
are
be.
AC.
Yes, yeah, they're line voltage. So if it's 208,
They
they'll
can
be
be
208.
reversed by wiring.
No. So, but they can be flipped and put in the wrong direction. There is a little arrow somewhere on them that shows like which way the air is going, so you know. But yeah, generally cleaning these up. The other thing with these. With these filters, this is good because these ones don't have it, but they are shipped with a screw in them right here.
Right.
And a lot of times those screws do not get removed. So then the customers, the stores, they can't get these out to clean them. So you definitely want to make sure that those screws are removed so that they can pull these out, wash and clean them. These are really cheap. I mean, I always recommend that you guys have some with you because they get broke, they get lost easily. So just, if you need to replace them, it's easy. But you can take them to a sink, wash them, soak them, put them back in. But you definitely want to make sure these are nice and clean. If they get dirty, one that can trip that, but also if it gets hot enough, it will start to affect the screen. They might start complaining of screen issues, the screen coming in, the screen going out, things like that, and then just shutting off randomly. A lot of that has to do with overheating, and then it's just these are starting to get plugged up, it's starting to get too hot in there, and it's just affecting the controls and the boards and those things. So. Main disconnect is on the back, so off on. What else? Get everything in here. So on off, 2 high limits, circuit breakers for the element, solid state relays for the element. So notice there's only 2 solid state relays, but there's 4 chambers. So these are dual. So this is going to be 1 chamber. This is going to be another chamber on this side. This is going to be a chamber. This is going to be a chamber. So these are dual solid state relays. You may get into some ovens and there's 4 and they're individual solid state relays. You may get into others and it's dual. So we made a switch. During COVID, it was hard to get stuff. We just went with whatever we could get. So we started off originally with 4, and then we weren't able to get those. We were able to get these. We went to these, and now I think we just stuck with, they like these better anyway, so we kind of stuck with these. So.
In order to test one of these relays, to make sure it's working properly, can you walk us through that?
Yeah, it's pretty easy. So, right here, you're going to have a green LED light that comes on. Mm-hmm. So this one's already plugged in, so we can turn it on and see it if we heat it up. So we'll grab the bag. So here's our solid state relay. So this is going to be a 12 volt DC to it.
Do you have an ohms meter?
Yeah, there's some hanging up over there.
Oh, awesome. Let's get one.
Yep. Here's what I grab. I don't know
on
if
the
there's
wall or on the
if
pillar.
you guys have a step stool or anything, this one's up a little high.
Yeah, there's. I know at least one.
It's platform shoes.
Don't go stick.
Careful, it's hot.
Whoever wants to go up there, I don't need it. I've seen them before. So when we preheat, we usually preheat all chambers. So when I hit preheat, you're going to see all 4 of these lights should light up, all these little green LED lights. And also on the board, you should see these lights come up as well. So,
Right behind the pigtail.
all right, so we're going to go ahead and go preheat.
Oh, okay.
Okay, so the lights come on 2, 3, 4. There's 4 LED lights, and then you got 4 LED lights here. Okay, so this means that I'm setting power out, is what those 4 say. My chambers. This says I got 12 volts DC, so we can take our meter, we can verify that 12 volts DC is there, and that's going to be our 12 volts DC.
If we come into an oven that has 4 relays, can we downsize it to a dual?
If it fits on the dimmer, I assume. So here I turned off all but one of them, so we should have 1 green LED light on. You can see here's chamber 1 LED light on only. And then if I preheat it all again, it's going to take a second. There's chamber 2, chamber 3, chamber 4. And the reason it takes a minute, right? You notice they don't just, I preheat and boom, it comes on. Because the first thing that has to happen is we have to prove the fan's running.
Mm-hmm.
Okay, so it's always hot. You're just switching
Yep.
the other leg.
Yep.
Okay.
So we have to prove the fan's running first. We do preheat. When the fan kicks on, we let the fans run, and then as we prove the fan's running, the chamber elements are going to come on. So you guys have that meter. So then, let's see if I get my video down here somewhere. Should be running right about 12. Right now it says 11.9, 11.8, 12, so I'm good. So, by the way, you can check, verify it's running. You can go, hey, we got our green LED light on. It's calling for power at the control board. We got green LED at the solid state relay. And
So if those aren't functioning properly, do they blink or do they just not come on at all?
So they will eventually begin to blink, and that's what this guy does, right? So as this starts to come to temperature, so right now we're cold. All of our preheats are 350, 450. So we're trying to get up to 450. Well, most ovens, when you get to 450, that's when it stops, and then we overshoot, right? So it goes 450, boom, oh great, shut off. But then we have this carryover to like 500 degrees. So on this, as we approach, you will see these start to flash and blink because we want to slow down that heat. So as we drive up to that set point, it starts to kind of curve off and comes into it. So as it gets closer, they will blink. Right?
So that's a normal thing.
That's a normal
It'd be the same thing as the speed of it. You can watch it blink.
So that is a normal thing. Not on at all. When they call for heat, it would be like, okay, what's going on? Especially if you got light here, right? If you have a light here calling for heat, and then maybe no light here. Okay, you got 12 volts DC getting there. Is there a bad connection, a bad pin? If the green LED light is on, 12 volts DC, do we have a bad solid state relay? We can check our amps, we can measure voltage across. Do we have 0 volts because it should be closed, so we should have 0 volts. Is it open? Those kinds of things.
You get 208 or 240 if it's open.
So now if we measure our, we go across A1 to A2, where we at? We're at 0, right? We're closed. And if I turn everything off, go across. Now we're at our 208, 213, 212. Right? So if our switch is closed, we should be at 0.
So that would be a simple way of checking to see if that's working, just by turning it on and off and making sure that you got.
So it's not a cross. It's those two, those two, those
Yeah,
two.
so you see, yeah, so, yeah, so it goes these two and these two.
Okay.
What are some other common troubleshooting with the ohms meter? Why we have it out to diagnose problems with the oven that you've come across?
What's that?
What are some other things that you've seen that failed that you needed the ohms meter to help diagnose? Maybe we could talk about it a little bit because this is where our guys struggle the most.
All of it, I mean,
Yeah.
meter's like the number one tool, right, when you're in here. So I guess it really just depends on the problem and what you're trying to track down. So at that point, this is pretty down. We can take this side panel off.
One of the problems we're having, like that ticket I've talked to you about that's been open a long time, is we have the shelves, they're not heating up in the back, but they're heating up at the front. But the temperatures to the chambers still aren't getting high enough. The shelves have been put in properly. What would be the cause of that? Where would you start? I know it's hard not to diagnose it, not having it in front of you right now, but could you give us some starting points if we can't get the service technician out there?
I really want to check those motors. Because if it's getting hot in the front,
It's getting hot on the front, but not hot in the back. And it started with only 2 shelves, and now it's all 4 shelves.
it's an interesting thing.
How do they know that? Just put it in the back so it's cooking?
But it's not using the temp at all.
Yeah, it started, with the food in the back not cooking properly, food in the front cooking properly, and then actually putting, actual temp gauges in the back to the front and seeing the variance.
I'm sure the jet plates are put together correctly.
Yes.
The 2 pieces are together.
Yes.
correctly, and those are slid in.
You do it like the surface thermometer in the back.
Let it get the food right.
Yep.
That's 99% of the problem.
That may not be that problem, but it is something we see in procedures. We see like, hey, this product has to come out of the freezer, has to go in the lock-in, has to defrost for 2 days.
Pizza is a big one.
And
that I
then
see.
they're putting it, they're trying to use a recipe meant for, a thawed-out product with a frozen product, and then they're complaining that the product's not coming out.
Yeah.
Well, it's because your procedures are to let it thaw. You're not doing that.
Right. That's a big
So
part
it
of
is
it.
a good thing to just think about.
We've definitely taken out human error out of this equation. So,
So there's that oven.
the oven.